I'm trying to make some citric acid. I could do this with lemons or I could do it with mold. Which one am I going to do? Don't matter because it's going to be easy either way. So we're going to do both. Juice from lemons and limes is like 5 to 8% citric acid, which that ain't bad. That's a good amount of citric acid, but you can get way more citric acid into a solution by having a bunch of mold ferment sugar into citric acid in that solution. It's just faster, it's easier, it's more efficient, and you don't have to grow a bunch of fruit to do it. But yeah, I'm gonna outsource the fermentation part because thankfully I know somebody who knows how to do that.
The mold that we're looking for is called Aspergillus niger. If you've ever seen like black powdery mold on an onion, that's what we're looking for. So actual first step was to find an onion that had a bunch of this black mold on it. So just imagine me at the grocery store looking around for the grossest onion. Once I found the mold, I needed to grow up enough of it to actually start a culture. And I did this using potato dextrose media. Really what I did here, I made it myself. I boiled a bunch of potatoes, I filtered out all the chunks, and then I added some sugar, and then I have a media that the aspergillus will grow in, but I wanted to start it on a plate, so I stamped my onion top onto some plates like this. After I let that sit for a while, oh, it's so gross. Then I grew some Aspergillus niger. It's kind of crazy because you grow plates upside down so that they don't flood when like the water cycle happens. So looking at it from the top, the Aspergillus first looked white and I was like, oh, I grew the wrong thing. And then I flipped it over and there's our black mold. Once I had enough of the black mold to start a culture, then I needed to give it something to ferment. So the fermentation broth uses molasses as a sugar source for the aspergillus. But the problem is that a lot of molasses contains some metal ions that can interfere with the process. So I'm going to gently heat a little bit of the molasses with some of this potassium ferrocyanide, and that's going to help pull those metal ions out. I split the resulting treated molasses solution into 2 batches, and I gave one an additional nitrogen source just to see if that might help the fermentation along a little bit. So I dropped my mold into my conditions, let it sit and ferment for a few days. Ideally inside the broth, this whole diagram is happening. We have glucose turning into citrate and like pyruvic CoA is in there and like the Krebs cycle is there and the whole gang from biochemistry is here. But I can't see if any of that is happening. All I know is that I grew some more mold.
And now I'm giving the mold broth to Chem Thug to see if he can get any citrate out of it.
I hope so.
Before I can get the citric acid out though, I gotta check this mold broth for this other acid, oxalic acid, because that one might mess me up later. Oxalic acid kind of shows up as a byproduct of the fermentation, and it will also bind to calcium, which is what I'm going to do in the next step. Now, once I add this calcium hydroxide solution, if there's oxalic acid in here, we should see some solids precipitate out. And I don't see anything. Nah, there's nothing happening here. I got this citric acid solution from the citrus juice and the mold broth, right? And I need to get the citric acid out of the solution. And I'm gonna do that by turning it into something that can't stay dissolved in the water. And that's more or less the heart of this whole process, is like playing with the solubility and controlling the solubility. First step, sodium hydroxide. This here, strong base. It's gonna pull all the protons off the citric acid. That will let me pull the sodium citrate out of the solution as something slightly different. Sodium hydroxide is also gonna react with a lot of other things in the lemon juice though, and that's why the color changes, because a couple of those things, when the pH gets high enough and the solution gets basic enough, it goes from like that yellow color to that orangey color. I now have my solution free of lemon bits, mostly just, you know, sodium citrate and a bunch of other things that I don't care about, right? But I can get the sodium citrate out and leave all the other stuff behind by converting it to calcium citrate. So I'm going to add some calcium chloride, and calcium is going to attach itself to those citrates. It's going to kick the sodiums off and it's going to grab onto those citrates. And it's going to do that because when it does that, it falls out of solution as a solid, right? Love this precipitation, yo. I love precipitation reactors. They're so gorgeous. But this is now a solid that I can filter. Definitely did not settle nearly as much as I hoped it would over the last 2 days that I left this. I guess my vacuum pump's just about to be real busy. Filtering that solid, by the way, ooh, man, yeah, that took way too long, way too long. So I repeated the process a few times just to make sure I got as much as I could out of this. You know what I mean? I do want as much citric acid as I can. So I knew that I might be leaving some calcium citrate behind. But here we are with, you know, what we got. It is not an amazing amount, but it is what it is. And now I got to do the same thing with the mold broth And it's more or less the same thing. It's just a slightly different mess. You know, I'm going to shortcut it, and I'm just going to make it basic with some calcium hydroxide. You know, because the calcium hydroxide is still a base, and it will still pull the protons off the citric acid and make me that citrate. But it comes with the calcium. You feel me? So the calcium will just react right away, and I get my calcium citrate. Now I just got to give it a little heat, and once I do that, you're going to start seeing the calcium citrate crash out. Which here, yeah, nah, this is going a little faster than the lemons. That's nice. I definitely take that. Now, if you use molasses as a feedstock, you know what I mean, you're going to get it looking like this. It's going to look ugly and gross, and the molasses is just going to stick to everything because it's molasses. And it's kind of ugly, yeah, and it's definitely contaminated, sure, but like in industry, they do it this way, and also like they clean it up better, and it's going to get cleaned up, you know what I mean? It'll definitely be cleaner by the end of this process, for sure. Now, same deal with the lemon juice. I'm going to repeat the steps a little bit just to make sure I'm squeezing everything I can out of this broth. You know what I mean? I want to get all the citric acid I can at the end of this. Especially because the liquid still looks kind of cloudy, which kind of means that there might still be some in there. Compared to the lemons, the mold broth has done this much faster and with way less effort. I just wish that this solid was pure calcium citrate, but it's not. It's calcium citrate with the molasses stuck to it, basically. Hopefully, it's not going to be a problem later. And the next thing we're going to do is flip this calcium citrate back into citric acid. And to do that, I'm going to add some sulfuric acid to it. Ooh, can you hear that? Well, that got dramatic quickly. What's going to happen is the sulfuric acid is going to give its proton to the citrate and turn the citrate back into citric acid. That's going to dissolve. Actually, the foam is probably just the calcium citrate itself puffing up from, like, you know, the water that's, you know, boiling off, but not yet reacting, or turning into calcium sulfate, which is what you get when you do this reaction. Calcium is going to get kicked off, except once it gets kicked off, it's going to go hook up with the sulfate, which is left over after the sulfuric acid does its thing. And they make this stuff calcium sulfate, which is also just like water insoluble, just like the calcium citrate. Get it to about boiling and let it boil for about an hour. And that way I make sure that like all the sulfuric acid I added reacts with as much of the calcium citrate as possible, which, remember, there's excess calcium citrate in here, which is going to get filtered out in the next step. Yep, that's right. We got one more filtration to do before we're done. Stay tuned. You were promised a filtration. Here's that filtration. So here I got a bunch of citric acid mixed with other stuff that's making it yellow. I couldn't tell you what the other stuff is, but once I pour this into this beaker and boil off some of this water, which is why I didn't want to add a lot of water, eventually, well, first, a little bit more calcium citrate and calcium sulfate is going to come out. So I'm going to have to filter it one more time, but it's going to be quick. But then, once I get the volume down to maybe like, I don't know, 200 mils from the 600, then you're going to start seeing the citric acid crystallize out. Yeah, that's what we're going for. So now I got the calcium citrate from the mold broth, and I'm going to turn that into citric acid using sulfuric acid again, because the chemistry is going to be the same no matter where the calcium citrate comes from, as long as I do it right. But the protons from the sulfuric acid is still going to convert that calcium citrate to citric acid. It's going to kick the calcium off and make me some calcium sulfate that I can filter out. Yep, more filtering. So much filtering. This is a large part of chemistry. It just happens to be. But then I'm going to pour it out into a dish, and we're going to let it slowly evaporate. And after a little bit, you're going to start to see the citric acid crystallize out. It's quite a bit of solid, just like stuck to this glass. None of it really looks obviously like citric acid. So, and I don't really have instructions at this point. So I'm just going to lean on my general chemistry knowledge to try and get this cleaned up. If I rinse this with cold water, it'll dissolve a minimal amount of my citric acid product, and maybe I can transfer some of these solids to a filter paper. I don't know. Those look pretty clear and crystally. I'm going to test it. I'm going to see if we got citric acid. If it is, this solid will dissolve in water. Yeah. Doesn't look like it's dissolving. Not a good sign. Let's test it with baking soda. If it's citric acid, it should fizz. There is zero fizzing. Oh boy. This really has been a monumental disappointment. I am deeply frustrated. I'm like actually kind of upset. I'm not gonna front. Like, try not to cry about it. I've isolated so much material from this whole endeavor, and none of it is citric acid. I think what I got was just too dirty and wasn't enough. All right, let's see what the lemons got for us. Maybe the lemon extraction went better. Let's see if these solids will dissolve in some water. It's not dissolving as quick as I'd expect citric acid to dissolve. That is very true. That's not a good sign. Well, let's see what happens. I sprinkle a little baking soda on it. Oh, there's some fizzing. There's fizzing. Not as much as I might expect that this was citric acid. But why isn't it dissolving? That's so weird. I don't know what this is. I don't feel like this is citric acid. It's gonna do it again. I've been working on this for 2 months. I feel like I gotta turn my degree in or something. Because I'm pretty sure the answer is just that I didn't have enough calcium citrate to start with. Pretty sure that's why. I'm not doing a comparing or a testing chemistry anymore. I'm just trying to like make this happen. You know what I mean? I'm just like pissed, yo. Like I'm straight juicing lemons angrily right now. So you've seen this part. We just gonna montage our way to 189 grams of calcium citrate because I'm tight. I'm tight. This should have worked. I don't know why this wasn't working. I am pretty proud of myself for isolating all of this. I ain't going front. This is a lot of product. I feel pretty good about this. But I'm not gonna calculate a yield and make myself feel bad. Instead, I'm just gonna flip it again. I didn't have any problems getting the calcium citrate. I had problems getting the citric acid. If I wanna consume all of this calcium citrate that I got here, the full 189 grams or so, I'm gonna need about 118 grams of my sulfuric acid. That is a horrifying amount of sulfuric acid to have to weigh out. I'm chilling this sulfuric acid solution in some snow because the colder it is, the less danger it poses. I'm also putting the calcium citrate on the snow so that it's also very cold. And when I mix the two, it should be very calm. It's definitely not being crazily dramatic. It is so calm. Yeah, this is nothing like the mold broth. And if you look close now, you can see that the solid in there, it's not quite as like tan, it's a little whiter, and that's the calcium sulfate forming. And that is essentially the same stuff that's in drywall, and that I am going to just filter out. There's 189 grams of calcium citrate. It's like it should be almost 150 grams of citric acid in there. And what I should be left with is a solution very, very rich in citric acid. Should. So now I gotta get this water out and I gotta make the citric acid crystallize. We're just gonna put it in a bigger drying dish. We're just gonna dry it all up and I'm gonna deal with the residue afterwards. I can't help but imagine though that this would have been way easier with the mold broth. Just like, But anyway, we got these lovely square-shaped crystals. So cute, look at that, so good. And I'm pretty sure that's actually citric acid. It's just swimming in sulfuric acid sludge with some calcium sulfate sprinkled in for flavor. But of course, there was more calcium sulfate, you know what I mean? But the excess sulfuric acid does mean that more calcium sulfate might form. So it's kind of silly of me to think that that wouldn't be a thing. But it's okay, it's okay. I've gotten very good at filtering and evaporating liquids at this point. I am like the best at that. But this time, I got me a fat solution of citric acid that I already know is not gonna crystallize the way I want it to. I think I figured something out. Citric acid does dissolve in acetone, but not nearly as well as it dissolves in water. So what I think I can do here is I think I can just crash more of it out with acetone. This is so exciting. This is so exciting. This might be the end of this journey, and I am so excited. I don't know why I waited to try using an additional solvent. When I add this to this, should get a whole bunch of solid just falling out. Ooh, look at that. Yeah. Oh man. Look at that. Wow. Although I think it's actually just like, I think it's phase separated. It is. It's like a straight phase separation. So the top layer is mostly acetone and the bottom is like a mixture of acetone and water. As they're mixing, I guess, it's forcing the citric acid out of solution. Let's go with a little bit more. So this is not a recrystallization. This is very much a precipitation, but most of what's in this liquid is citric acid at this point. It's gonna be relatively clean. It feels like a mild miracle that I was able to make this happen in the scope of time that I managed to make this happen. Even I know that this is like known and solved chemistry, sure, fine, but like I don't have facilities and like access to a lot of things. So I feel accomplished. I feel super accomplished. And this whole thing has been fun. I take a little bit of this solid, throw it in this here test tube. Let's see how well this dissolves. Oh, look at that. Oh, look at that. Oh, would you look at that? Looks like it's going. Look at that. Gone. Gone. It's dissolved, baby. It's dissolved, baby. It's gone, baby. Yeah. This is a monumentous moment, man. This is monumentous, man. Just let you know, if this fizzes, I'm going to be so sad if this doesn't fizz. I'm going to be so sad and confused. Like, I'm going to be so sad and confused if this doesn't fizz because it dissolved perfectly. Oh, there it goes. There it goes. It took a second for whatever reason, but it's definitely fizzing. I can see it fizzing. It may not be pure. It's definitely citric acid. Now that I know what to do, I just want to make like a giant mold broth. Like, I don't think I'll ever buy citric acid for my lab again. Definitely still buy it to eat it though. I don't trust myself.